Hello students, we will be discussing about properties of amines today. Firstly about physical properties of amines. About state of these, the lower members of aliphatic amines are gases having ammonia-like odor, while the higher members are mostly liquids with fishy smell. Aromatic amines are either liquids having characteristic unpleasant odor or low melting solids which are almost odorless. Amines which are almost colorless, they develop color when exposed to air, they get oxidized and form colored oxidation products. Melting and boiling points of these amines being polar because nitrogen is electronegative element form intermolecular hydrogen bonding. This is methylamine CH3NH2. This is another molecule CH3NH2, another molecule CH3NH2. Nitrogen of this molecule and hydrogen of other molecule, they form this weak hydrogen bond. Similarly here, hydrogen of this molecule which is attached to nitrogen and nitrogen of other molecule, they form weak bond between them which is called hydrogen bond. This hydrogen bonding is weaker in comparison to hydrogen bonding which is existing in alcohols and carboxylic acid, and hence the boiling points of amines are lower in comparison to alcohols and carboxylic acids of comparable molecular mass, but the boiling point of these amines are higher in comparison to nonpolar compounds where there is no hydrogen bonding in them. The lower amines, these are quite soluble in water, that is again due to formation of hydrogen bond with water. Amines, they form hydrogen bond with water. Since all of them can form hydrogen bond with water, however, amines with 6 or more carbon atoms, these are not soluble because the R part has increased, and due to this increase in size of nonpolar hydrocarbon part, hydrogen bonding becomes less effective. About stereochemistry of amines. Amines in which nitrogen carries 3 different groups like this. One is methyl, other is ethyl, another is propyl group. So this is tertiary amine in which the nitrogen is having 3 different alkyl groups. These can exist in 2 forms, this form and this form, and these two are non-superimposable mirror images of each other. So the amine is dissymmetric, or we can say chiral, and as such it should exhibit optical activity. Practically, amines are not known to exhibit optical activity or an enantiomerism because these 2 forms, they interconvert into each other by rapid inversion, or we may call it flipping. So these 2 cannot be differentiated from each other, hence no optical activity is shown by amines. However, quaternary ammonium salts are in which nitrogen is attached to 4 groups, and if all these 4 are different, we can see here this is methyl, phenyl, ethyl, and this is benzyl group. Lone pair of electron has been used to form bond, hence these compounds are called quaternary ammonium salts. These quaternary ammonium salts, in which nitrogen is attached to 4 different groups, this exhibit tetrahedral arrangement, and this arrangement does not allow flipping from one form to the other. Hence, these quaternary ammonium salts, these show optical activity in contrast to tertiary amines, in which due to flipping these don't show optical activity. About chemical properties of amines. First one, it is basic nature. These amines, these act as bases because there are lone pair of electrons on nitrogen in all classes of amines, that is primary, secondary and tertiary as well. And this basic nature is reflected from number 1, formation of hydroxides. Substituted ammonium hydroxides are formed with water. This is primary amine, RNH2. Nitrogen is having lone pair of electron. When water is added to it, it forms substituted ammonium hydroxide. 1 water molecules gets added on this amine. This was RNH2. When water molecule is added, it forms RNH3OH by the addition of water molecule, which can dissociate to give RNH3 positive and OH negative, because it is furnishing hydroxide ion. So, basic nature of amine is being reflected. Likewise, secondary amines and tertiary amines also, when water is added to these, they form ammonium hydroxides, R2NH2OH, R3NHOH, which dissociate to give R2NH2 positive ion plus hydroxide ion, and in tertiary amine R3NH positive plus hydroxide ion. So all these 3 classes of amines, they furnish hydroxide ions when water is added to these, so reflecting the basic nature of amines. Second property which reflects the basic nature is formation of salts. Amines react with acids, here primary, secondary and tertiary amine. They react with acid HCl, forming amine salts RNH3 positive Cl negative, R2NH2 positive Cl negative, R3NH positive Cl negative. 1 HCl molecule adds up to amine molecule and these amine salts are formed. All the amines, these are weaker bases than hydroxide ion. Their salts are these salts. These are readily converted back into free amines by aqueous hydroxide ion, RNH3 positive plus OH negative hydroxide ions. They get converted to free amine, RNH2. Water is formed. Second property of amines is reaction with metal ions. As amines, they have unshared pair of electron on nitrogen. These can act as ligands, and these ligands, they react with, for example, AgCl, silver chloride and copper sulfate to form this complex is formed, complex ions are formed, coordination compounds are formed. Here with AgCl, two amine molecules, in this case methylamine has been taken. Methylamine this react to form, here it is hydrogen, here also hydrogen, methylamine molecule, another methylamine molecule coordinating to silver metal, and this bis methylamine, two molecules of methylamine, hence it is bis methylamine. This name is to be written in bracket. Silver 1 chloride. You have already studied coordination compound, so you can understand the name of this compound, coordination compound. This is soluble complex, and with copper sulfate, for example, if ethylamine is taken, coordination number of copper is 4, coordination number of silver was 2, hence 2 ligands were coordinating it. Coordination number of copper is 4, so 4 molecules of ethylamine, C2H5NH2, C2H5NH2, C2H5NH2 and C2H5NH2, 4 molecules, these are coordinating on this complex ion, plus 2 charges there, and sulfate ions, these are there in the solution. This is deep blue colored complex. Third property is alkylation. Amines with alkyl halides, these form secondary amines, tertiary amine, and quaternary ammonium salts are formed. This process, up till the amine, primary amine, gets converted into quaternary ammonium sulfate salts, the process is called exhaustive alkylation. If here methyl halide is taken, the process will be termed as exhaustive methylation. Here alkylation word has been used because R is taken here. Next property is acylation. Primary and secondary amines, but not tertiary. These react with acid chloride and acid anhydride to give N substituted amides. N means nitrogen, RCOCl, RNH2. Here in this reaction, H from here and Cl from here, one HCl molecule is eliminated out, and acyl group, RCO group is termed as acyl group. In place of one hydrogen of amine, RNH2, one H has been substituted by acyl group. So these are termed as acyl substituted amides. Alkyl substituted, alkyl is this R, alkyl substituted amide. Amide is RCONH2, and in place of one H here, R has been substituted, so it is termed as alkyl. Alkyl is on nitrogen, hence it is called N for nitrogen, N-alkyl substituted amide. Acid anhydride and treated with amine, RNH2 primary amine. Here also acyl group has been introduced in amine in place of one H, RCONHR. This is also alkyl substituted amide, along with the formation of RCOOH, R dash. Here it was R dash CO twice O. Acid anhydride was containing R dash group. And if secondary amine is taken, R2NH, and is treated with acid chloride, here also HCl molecule is eliminated, and with the elimination of HCl, RCONR2, here on nitrogen, two alkyl groups are there, hence it is called NN, two times nitrogen, because two alkyl groups are there. NN dialkyl substituted amides are formed with secondary amines. Tertiary amines, they don't contain any hydrogen in them. R3N is the formula for tertiary amines. Hence, no elimination of HCl, no reaction of tertiary amine with acid chloride or acid anhydrides take place. If the amine, acid chloride or anhydride, one of the reactant of these reactions, if one of the reactant is aromatic, either the amine or acid chloride or anhydride, the reaction is termed as Schotten-Baumann reaction. And then the reaction is carried out. Here amine is aromatic one, aniline has been taken, and it is treated with acetyl chloride. In these cases, the reaction is carried out in presence of some base. Here pyridine is taken as base. In presence of pyridine, H from here and Cl from here, HCl is eliminated, and the product N-phenyl amide, acetamide, the common name for this is acetanilide, because C6H5NH2 is aniline and acetyl group is introduced in place of this H, so it is known as acetanilide. CH3CO group is termed as acetyl group. So the name of this compound, common name of this compound is acetanilide. Similarly, if the acid chloride is having aryl group, this is aromatic one, acid chloride. This is also Schotten-Baumann reaction. This when reacts with secondary amine, similarly HCl molecule is eliminated, and with the elimination of HCl, C6H5CON, this H has been removed, this Cl has been removed in the form of HCl, and C2H5 twice. About mechanism of this reaction, lone pair of electron present on nitrogen that attacks on carbonyl carbon because it is electron deficient due to withdrawal of electron by oxygen. Oxygen, this acquires negative charge, and when this comes back, Cl is removed as Cl negative. So with the elimination of chloride ion, RCO, here double bond was formed, C double bond O, N is acquiring positive charge because through its lone pair of electron it had attacked at carbonyl carbon. So RCO NH2R, and an N is having positive charge on it. When from here one H positive is removed, RCONHR, alkyl substituted amide is formed. Tertiary amines can also act as nucleophiles. R3N, through its lone pair of electron on nitrogen, it can attack on this carbonyl carbon similarly, and oxygen is acquiring negative charge. When it comes back, Cl is eliminated as Cl negative, and RCO and positive R3 and had acquired positive charge because through its lone pair of electron it had attacked that carbonyl carbon. Now this compound, it does not contain any hydrogen, so it cannot lose H positive. So stabilized product cannot be formed in this case, hence no reaction takes place in case tertiary amines react with acid chlorides. Fifth reaction, that is conversion into sulfonamides. Sulfonamides we have discussed earlier when these amines react with Hinsberg reagent, para-tosyl chloride, that is toluene, C6H5CH3 is toluene, and when at para position sulfonyl chloride is introduced, the reagent is known as Hinsberg reagent, and the Hinsberg reagent, we had discussed it in separation of amines, primary, secondary and tertiary amines. There was a method of separation, Hinsberg method, in which Hinsberg reagent was used, sulfonamides were formed. Next reaction, 6.1, is reaction with nitrous acid. This reaction is very important synthetically. Many compounds are synthesized through this reaction. Primary aromatic amines like aniline, they react with nitrous acid. Nitrous acid is not stable. It is formed in situ. In situ means in the reaction mixture itself, the aniline is added or any aryl amine. NaNO2 and HCl are precursor of nitrous acid. They produce HNO2. These are mixed with some aromatic amine, and the temperature that is maintained below 5 degrees centigrade, that is 273 to 278 Kelvin temperature is maintained. During this, diazonium salts are formed. Ar, aryl group, N2, diazo. Azo is being used for nitrogen. Diazo, 2 nitrogen, having positive charge. So diazonium, Cl negative chloride. With the formation of NaCl and water, diazonium salt is formed. Hence, the process is known as diazotization. Primary aliphatic amines, these are of no synthetic value because here in this reaction, nitrous acid and NO2 and HCl at 273 to 278 Kelvin temperature, when react with aliphatic amines, these form Rn2 positive Cl negative, that is alkyl diazonium chloride. This is unstable species and immediately it reacts with water to give alcohol ROH plus N2 nitrogen is evolved along with formation of alkene and alkyl halides. Hence the reaction is of no synthetic value. But this method can be used in estimation of primary amino group because nitrogen is evolved here and it is evolved quantitative proportions. It is evolved in quantitative proportions. Depends upon the quantity of amino group. So to estimate the primary amino group, the method is used by measuring the amount of nitrogen gas evolved. The estimation of primary amino group can be done and the method is known as Van Slyke method. Secondary amines, these react with nitrous acid, that is NaNO2 and HCl, to give N-nitroso. This N double bond O group is nitroso group attached on nitrogen, hence called N-nitroso. Dialkyl R2 dialkyl amine, N-nitroso dialkyl amine, R2N, N double bond O, along with formation of NaCl and water. When in this reaction mixture a crystal of phenol and sulfuric acid is added, a green colored solution is formed. When water is added to this solution, it turns red, and on adding alkali to this solution, it turns deep blue in color. The reaction is known as Lieberman's nitroso reaction. This is a test for secondary amines, Lieberman's nitroso reaction.